Before we move on to the functional groups, let's do 2 questions right here to give us a better grip on the rules of IUPAC naming. So here's the first one right here in front of you. If you want to try it, you can just pause the video and see for yourself. Okay, I'm assuming that you paused the video and figured out the answer. So let's get going. Let's see. So obviously the first step that we're gonna do here is find the longest chain, or find the parent chain. So what we're gonna do here is we're gonna find out the chain. So 1, 2, 3, 4, 5, 6, 7, 8. That's an 8-membered chain right there. But we've also got another chain. Actually, we've got many chains here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We've also got the same one. So all the way till here, the same. But here, once again, these two are identical, so we don't really need to consider that. I mean, why are they identical, you could be asking? Because when we're talking about the red chain, this would be a substituent here. And when we're talking about the green chain, this would be a substituent here. And that substituent is placed relatively in the same position. So hence, we don't really need to consider that many chains. So I'm just gonna okay, we'll still use this. That's one of them. Now another chain that we could consider is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now here is a 10-membered chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just making sure that I counted it correctly. But yeah, so we've got an 8-membered chain, we've got a 9-membered chain. Actually, we've got 2 9-membered chains, which are both identical, so we're not considering 2, we're just only considering 1. And we've got a 10-membered chain. Now, I mean, there's also a smaller chain, which is 1, 2, 3, 4, 5, 6, 7. We've got a 7-membered chain too, but honestly at this point there's no need to consider that. But yeah, so let's see what we have to choose out of all of these. Now, as I've mentioned before, it's not only the number of carbons that matters, or the number of carbons in the chain that matters. In fact, we have to look at the substituents and the branching and whatnot. So we have to look at all of that before deciding our final parent chain. So let's look at the yellow chain first. I'm going to erase all of these dots right here. Actually, wait, I think that's important for us to remember. Okay, I'm taking out the 7-membered chain because I don't think it really matters at this point. Actually, let's discuss that as well. When we're considering the 7-membered chain, I'm going to highlight it right here. Color's not according to it though. That's our 7-membered chain. And when we're considering the 7-membered chain, there's only one substituent, which is this big one. Only one substituent to it. And I think we've got better chains available than that. Now, when we're considering our 8-membered chain, which is this, we've got 2 substituents. One is this, and the other is that. So we've got 2 substituents. Okay, I'm going to make a note of that right here. And now, let me just, when we're considering the other chains, like the red chain, this chain right here, when we're considering it, we've actually got 1, 2, 3 substituents present. So for the red one, we've got 3 substituents. In fact, for the green one also, we would have 3 substituents because it's this. So we've got 1, 2, and 3. That's also 3 substituents. So let me just jot that down. So both have 3 substituents. Let me erase. Okay. Now let's look at the final chain, which is the 10th chain. The 10-membered chain. And when we're looking at this, we found out that there's 1, 2 substituents. So there are only 2 substituents for this chain. So overall, looking at this, we figure out that the 9-membered chain is actually a better option here because it has 3 substituents, whereas the 10-membered chain only has 2. So that's what I meant by longer chain doesn't necessarily mean parent chain. In fact, you have to check the substituents present. So let's continue. So these right here are our possible locants for this compound. I just went ahead and, drew them out. So now what I'm going to do is that I'm going to figure out the lowest locant set. So what we're going to do here is I'm going to write down the locants for each. So this has a locant of 4, 2, and 5. And in the green case, this has a locant of 6, 8, and still 5. So those are our lowest locant sets. I'm just going to circle them so that we separate them from the rest. Now from each possible case, what is the lowest set of numbers that we could get? Is it 2, 4, and 5? Or 5, 6, and 8? Obviously here, our lowest locant set would be 2, 4, and 5 because obviously they're lower numbers than the previous one. Than the other one. So now all it comes down is with the naming. Now, okay, we're going to follow the blue locants here. So I'm going to erase the green locants. So we don't need these. The blue locants are the ones that we want. I'm going to erase these as well. Okay, so now let's get on with the naming. So, okay, let's identify the substituents. This is CH2, CH3. So this is ethyl. This is 1, 2, 3, 4 carbons present. So this is actually butyl. And here is 1 carbon present, so this is methyl. So these are all of our substituents that are present in this compound. Now, as I've mentioned before, right here, alphabetical order is very important. So when we're arranging these in our name, we have to arrange them in alphabetical order. So just watch closely and understand. So here we've got a B, an M, and an E. These are all substituents, and as I've mentioned before, our prefix contains our substituents or branch. So that's what we're going to look at right now. We're talking about our prefix. So since B is earlier in the alphabet compared to E or M, our first substituent mentioned is going to be butyl. So there's a 4 butyl. comma. And the next thing is E, because E comes before M. So then we've got 5 ethyl, comma. Also, you have to separate your substituents with a comma, by the way. And your locant and substituent are separated by a dash. And then finally, we've got 2-methyl. So those are our substituents, aka this is our entire prefix. Now let's get on with the root word. So here we've got 9 carbons present in our parent chain. So obviously our root word would be non. So this is our root word. I'm just going to write it as RW. And there are no double bonds or triple bonds. It is a fully single bonded compound, and hence we use the primary suffix of -ane. So this is our primary suffix. And that's pretty much it. There are no functional groups present in this compound, so we do not use a secondary suffix in this case. So our final, compound name or IUPAC name would be 4-butyl, 5-ethyl, 2-methyl nonane. So that's our compound name in this case. Let's go on with another example, which I will draw right here. Now this is the next compound that we have. So you can give this a try. So I'm just gonna let you pause this video and figure it out. I'm assuming that you've figured out the answer, so let's go through the process once. So obviously the first thing that you want to do is find out the parent chain. Now there are many chains possible here, but we'll just directly go and find the longest one. Let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a 9-member chain. And there's also many other types of chains possible here. You could go on and figure them out. So there's one here, here. This is one, but there's only one big substituent, and that too, it's pretty small. So we don't need to consider the red chain. Now you could also use this. But it has, let's see, 1, 2, 3, 4, 5, 6, 7, 8 carbons, but it has the same number of substituents. So since the 9-member chain is longer, but also has the same number of substituents as the 8-member chain, we would prefer for the 9-member chain. So similarly, we'll find a bunch of chains which can be tested against the idea of this 9-member chain, and hence at the end we would get that the 9-member chain is the best chain possible. And hence this 9-member chain right here is our parent chain. Now let's identify all of our substituents. And this is 1, 2, 3. 3 substituents, and each of them are a CH, CH2. All of them are that. So this substituent is called an ethylene. That's what this substituent is called. Now all 3 of these are ethylene substituents. Now what we're going to do here now is find out the lowest locant set. That's pretty easy because this compound is symmetrical. Like there's the same numbers. Let's just write them down. 4, 5, 6, 7, 8, 9. And the other set, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since, you know, they have the same numbers present, it's just in different counting style. But either way, the locants are the same, and hence this compound is symmetrical. We could just directly, without a doubt, just say that the locants are 4, 5, and 6. It doesn't matter whether you're going with the red locants or the blue locants. Either way, you'll get the same. Now, let's just try to name this. So, as per our previous knowledge, we could do this. Okay, so we've got 3 ethylenes here. And ethylene is a relatively small substituent compared to phenol or something. So, as I've discussed previously, when we have multiple of the same substituent, we have to use one of these. And since in this case, we have 3 ethylenes, we'll have to use tri. So let's go back to our compound and figure this out. So we've got 4, 5, and 6, and 3 ethylenes. So what we're going to do here is we're going to write 4, 5, 6 triethylene. This is our prefix. Now let's get on with the root word. So our root word here is non, because there are 9 carbons in the parent chain. And since here we've got 1, 2 double bonds, let's highlight that, 1, 2 double bonds, we have to use -ene. But since we have 2 here, we're going to have to do the same thing like how we used tri. We're going to have to use di instead because there are 2. So what we're going to do is do di, do like a dash, and there's 1, if I'm using this counting scheme, either way, there is a double bond present at the first carbon and a double bond present at the 8th carbon. So this would be non 1, 8 diene. That's how we would name this compound right here. So yeah, that is, okay, let's talk about the parts. Okay, this is the root word, and this is the primary suffix. Once again, there are no functional groups, and hence we do not talk about the secondary suffix in this case.